Hey everyone, this is Derek. In this video we're going to look at, basically it's an introduction to function notation and that f of x that you might have some memories of running into before. So we're going to look at kind of two distinct things in a few different ways. We're going to have problems where we're going to have things like, well right here, where we have f of some number, like 3, for instance, and we're going to have other problems where we have f of something equals a number. So these are kind of the two ideas that we're going to try to separate out, and then we're going to do that for ordered pair, tables, graphs, and equations. So we're going to look at kind of several different ways they can be formatted, but these two ideas throughout those couple of ways. So let's talk about the notation a little bit. So this notation y equals f of x. So f of x is going to kind of stand for the y side of the equation. And as I just said, it's read f is a function of x, or y equals f of x. X is going to be our input value, so that's like quite literally x, right? So we put in x's. So if this says 3, like here, that would mean we'd be plugging in 3 for x. And then f is the symbol that denotes the function rule. So like in the last video I said, let's say we had some input x and our rule said add a 3 to it. And then that gets us to our output y. So our input, that's x, that's our independent variable or the argument. Our rule f in words would be add a 3 to the input, and then y is the output or the dependent variable. It's what happens after you apply the rule to the input. And again, from the last video, for each input we only get to have one output. So what this f is really doing again is symbolizing whatever mathematical operations are happening to your input. So it could be, square the input, add 3, and then divide by 7. And that's what that f is standing for, is all those words I just said. Okay, so that's sort of what the y equals f of x means. And then down here, super important, this f of a and f of x equals a. So f of a, when we have the number in the parentheses replacing the x, that straight up means x equals 3. Plug that in, the x, you're going to go find y. When we have f of x equals a value, like f of x equals 3, remember back up here, y is the f of x. So this is saying y, and now you need to go solve for your x value. So f of a something, x, you're looking for y. F of x equals something, y, you need to go find x. Let me show you how that looks with a few different examples. Okay, so this problem is actually kind of 4 examples in one, and this is how it will look on the homework. And so for this first one, we're talking f, and then it'll be g, p, and then h. So the graph is representing the f of x, g is this ordered pair here, and p is the table, and then h is going to be this function, is how that all kind of lines out. So looking at the first one, we're asked to find f of 4. So again, this means we know x equals 4, and we're trying to figure out what y would be. And f is the graph again, so when f is 4, it looks like the y value that goes with that would be 3. So y would be 3, or f of 4 equals 3. Ignore that, that was just my cursor. Determine x when f of x equals negative 4. Okay, so f of x equals negative 4, that means the y is negative 4, and it's saying find x when y is negative 4. So we'll come over here, and there's y is negative 4, so we'll trace that across, and then we'll come up, and so it looks like x is negative 4. Evaluate g of 17, so we come down here to the function labeled g. G of 17, remember that's our x, and so what we're looking for is a y. So we'll scan through the table, and it looks like right there, when x is 17, the output of the y is 66. So g of 17 would be 66. Next one is find the x when the y is negative 18, same one. So we'll just scan through, so it looks like it's right here. So x equals 40, so when I put in 40, I get out negative 18. E, so we're finding p of 9, so that's our x value. So it looks like when x is 9, p of 9 is 90. And then determine x, and I have a typo here, I corrected it in the notes, but those should be t's. So determine t when p of t equals 81. So scanning across for the 81, that looks like it's right there. And so it looks like t is 41, it gets you an output, a p of t of 81. And then h is this function right here. I'm going to slide the paper, give myself a little more room, and I'll do g right here, and then I'll do h over here, just so I have a little more space. So evaluate h of -1. Okay, so h of -1. Again, that means x is -1. So we're just dropping a -1 in for the x, because that's our input. And then this time we're not told the output, so we're just going to calculate it and then see what comes out. So h of -1 equals 19 minus 28, or h of -1 equals -9. So when I put in a -1, I get out -9. And then this one is determine h. So now we're solving for h when h of x equals 10. So we're literally putting the 10 in right there, because h of x is 10. So now I can write 10 equals -19x minus 28. And then to solve here, remember we would just add the 28 to both sides. We do our add subtract first, or multiply divide second. And that's going to make 38 equals -19x. And then we'll divide out that -19 to make this a 1. And we should end up at x equals -2.